Okay, so here we go. This is the process, and this leads you down through the process. And for the rest of the section while we're studying polynomials, until we change over to the rational functions, this is what we're going to be doing. So in this particular instance, it said, what's the maximum number of zeros I can have? This is a fourth degree polynomial. 4. It's the degree. And then the next thing we want to do is we want to list all possible rational zeros. Now remember, what we're going to be looking at is the divisors of the back divided by the divisors of the front. And that's why I just put B over F, and it's alphabetical order, so I kind of know from that. The back is, well, 8. What divides 8? Well, 1 does, 2 does, 3 does not, 4 does, 5 does not, 6 does not, 7 does not, but 8 does. So now I've got all of the divisors of 8. So I start at 1 and work my way through. What are the divisors of 1? Oh, I like that a whole lot, plus or minus 1. So I only have one choice. That means as I make my list, it's going to be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Now, what's the maximum number of zeros? 4 and 1, 2, 4, 6, 8. 8 rationals. That doesn't mean that there aren't irrationals, and that doesn't mean that there aren't imaginary, but there are going to be 8 zeros, not necessarily unique. Not 8 zeros, 4 zeros, not necessarily unique. Now, use your calculator to narrow the list, because remember, we're not doing Descartes' rule of signs, we're not doing upper lower bound rule, we're just going to narrow our list using our calculator. So, essentially, y equals, and I'm going to clear this out of there. It's a fourth degree polynomial, so I can't factor this by hand. So x to the 4th minus x to the 3 minus 6x squared plus 4x plus 8, and then I recheck it because the chances of me typing it into my calculator and making an error can be pretty good. Plus 8. Now, I notice that my list goes from -1 to 8 in the rationals. That means that our standard graphing window, which is minus 10, 10, minus 10, 10, that's zoom standard, is sufficient. So I'm just going to do a zoom 6, which is zoom standard. And then I'm going to use that to narrow my list. This is very typical, by the way, of a fourth degree polynomial. Notice it's got 3 humps. Number of turning points, maximum is 3, degree minus 1. And then I notice how many places? 1, 2, 3. Now, this either is a 0 of multiplicity or not. It could be. If it is a 0, it's a 0 of multiplicity. What I don't know is that what that graph could do as it comes down to the x-axis, because of my graph paper, my calculator, and my calculator really doesn't give me a good look, really, does it come down and touch, bounce back up? That means this is multiplicity 2. So I do have 3 of them, but one of them is multiplicity 2, which gives me 4. Or does it come down and look like it touches, but not quite? Now that would mean the other 2 zeros are imaginary. It's got zeros, but they're imaginary. Well, why? Because I've got 1, I have 2, I need 4. If this doesn't touch, I still have 2 more. And those 2 more will be imaginary, more than likely. The other thing it could do that I would not necessarily see is it could come down, it could cross just a little bit and go back up, and I can't see it. It just looks like it touches, but it actually comes down and crosses. There are lots of little subtle things it could do. That would mean I would give me the 2 that I see, and then there would be 2 that I don't see. I won't know until I check things out. Now, if I narrow the list, it looks like it is what? -2, -1, and +2, right? So, -2, -1, and +2. Can't, of all my list, it can't be anything other than those. Now, if this is +2, that says this graph touches. I'm looking at multiplicity 2. So what do? Remember, we hit trace, and now I can evaluate. And if I just hit negative, notice it comes up with an x equal. And I'm looking for a y value of what? 0, because then it is a 0. That's why they're called zeros. And it is. So that checks. And then, as long as I don't do anything, I can type -1, and I get 0, and that checks. And then I can type 2, and I get 0, and that checks. And that says that that graph does what? Touches, right, at 2. So this guy, it touches. So I have multiplicity 2. I've got them all. That's the nice thing. So that says that my zeros are -2, -1, and 2, multiplicity 2. So if I know the zeros, then I know the, begins with an F, factors. So this says that the factors would be x minus 2, or x plus 2, x plus 1, and x minus 2 to what power? So it says write in factored form. Well, we got it, that x to the 4th minus x cubed minus 6x squared plus 4x plus 8 is going to be equal to x plus 2 times x plus 1 times x minus 2 squared. Now, what's the leading coefficient? The leading coefficient what's the leading coefficient in this instance? 1. And that's what would go here. And you're going to say, well, why is that? Well, the zeros to this guy, we now know what they are. They're -2, -1, and 2. I make one itty-bitty little change. And what I'm going to do is I'm going to insert here. Actually, this is what I'm going to do. Well, no, I'll do that. I'm going to take -1 times that polynomial. I should get that same polynomial how? Flipped around. That polynomial with the leading coefficient of -1 has the same zeros. I could go back, do a vertical stretch factor of 2. Now my leading coefficient would be -2. It has the same zeros. I could put a leading coefficient of 3. Now I'm going to flip it around. It has the same zeros. So you have to take into account the leading coefficient. you have to take into account the leading coefficient. So that's why I look at what is the leading coefficient. This is the factorization. The leading coefficient basically determines which one of those graphs that I've just graphed it is. It's one of them.